Hello friends, today we are going to solve some GATE previous year's questions from the chapter Metrology. So this is a GATE question from the year 2014. So we will read the question first. It is saying which one of the following instruments is widely used to check and calibrate geometric features of machine tools during their assembly. So now looking at the options, first option says ultrasonic probe. No, it's not being used. Coordinate measuring machine. No, coordinate measuring machine is also not used to check and calibrate geometric feature. Laser interferometer. Yes, laser interferometer is an instrument which is used to check and calibrate geometric features of machine tools. So friends, option C is the right answer. Now moving to the next question. So now this is a GATE question from the year 2014. It's a question of match the following. So see, in the question they are saying that for the given assembly 25H7G8. See, this is a nomenclature for a hole and shaft arrangement. So first of all, you should know the nomenclature of hole and shaft arrangement, how they are named, and what does H, G, and 8 and 7 stands for, and 25. So do read the theory, and you will be very easily solving this question. So I am not going through the theory, just I will solve this question for you. So what is they saying? The option C says P is H. H is basically hole. So for P it's 2. Similarly, now they're saying Q IT8. Basically, they are talking about tolerance level. So IT8 is G8. Basically, they are tolerating the shaft tolerance grade, because H is here is hole and G is shaft, and IT8 is this 8. So 8 is the tolerance of shaft. So IT8 is shaft tolerance grade. So the answer is Q is for 4. Now the third one is R, IT7. So IT7 is basically hole tolerance grade. So R is 3. And G is basically shaft. So S is 1. So when you look at the options, P is 1. No, this option is not the correct answer. P is 2. Yes, this might be the answer. A possibility that that's P2. P1 again, this won't be the answer. P2, this is again a possibility. Now Q4, so Q is 4, so R is 4 here, so this will also gets eliminated. The right answer is option D. See friends, we can also solve it by elimination method, as I have already explained in the previous videos also. Here again also I will be explaining. So see, I am knowing that H is basically hole type, so P is 2. So since we know P is 2, so these two options are eliminated. Now it might be this or this. Now Q is basically IT8. It is the tolerance grade of shaft, so Q is 4. As soon as we know that Q is 4, so R can't be 4, so this also gets eliminated, and the correct answer is D. So it will save time in the competitive examination. Now moving to the next question. See, this is again a theoretical question. I would suggest that when solving the GATE question from the chapter Metrology, do read all the type of instrument which are being used in the in measuring or in inspection or in calculating the dia of hole. Please read it. So the flatness of machine bed can be measured using vernier calipers is not used to measure flatness. It is basically a length measuring instrument. Autocollimator, yes, autocollimator can be used. So the correct answer is option B, autocollimator. Autocollimator is an instrument which can be used to measure flatness. Height gauge and tool maker's microscope can't be used to measure the flatness. So option B is the right answer. Now moving to the next question. See, this is a GATE question from the year 2014. It might be looking a very big question as they have given a very big figure, but the question is very simple. I will try to solve it in this page. If it won't be able to solve, then I will move to the next page. So see, now what the question is saying, the diameter of a recessed ring was measured by using two spherical balls of diameter D2. So this is D2 they have mentioned here, 60 mm. So this is 60 mm. I'm writing here only 60 mm. And D1 is 40 mm. So D1 is this 40 mm as shown in figure. Now what they are saying, that distance H2. So this is H2. H2 is 35.55 mm and H1 is 20.55 mm. So what they are saying, the diameter D of the ring gauge in mm. Basically they are asking the value of this d is equals to what. So see, this is this is more of a mathematical question rather than a metrology or a interference fit type question. You just have to calculate using Pythagoras theorem. And they've also given the diagram in which they are showing that AB and BC and AC are forming a right angle triangle. So they have done most of the job. You have to just calculate the value only in this question. So now, what do we know? That AB is equals to R, as they have seen shown in the figure. So now we have to basically calculate the value of D. So before going to D, we have known that AB is equals to R, which can be written as, basically this distance is D2 by 2. From figure you can see, and this distance is D1 by 2. So R can be written as, or AB can be written as, D minus of D2 by 2 plus of D1 by 2, if you can see from the figure. Now what is AC? Basically AC is radius of this circle and this circle. So AC can be written as D2 by 2 plus of D1 by 2. Now the question is, what is BC? That's the main thing which will create trouble in this question. So you can say that, let's say I am extending this line like this, and like this also, this side, let's say. So we can write that this height can be written as, if you see from the figure, h2 plus of, I can write it as d2 by 2 is equal to BC plus h1 plus d1 by 2. Basically I am saying that this height plus this height is this one is equal to this height plus of this height plus of BC. So now BC can be written as h2 plus d2 by 2 minus of h1 plus d1 by 2. I am writing BC value again, h2 plus d2 by 2 minus of h1 plus d1 by 2. So now I will put all the values. So what is AB coming? AB is coming as d minus of d2 plus d1 by 2. So d2 is 60, d1 is 40, so 60 plus 40 is 100 by 2 is 50, and capital D we don't know, so d minus 50. So AC is again d2 is 60, d1 is 40, so 60 plus 40, 100 by 2 is 50. And what is BC? See, BC is basically h2 minus h1 plus d2 minus d1 by 2. So h2 is 35.5 minus 20.55, so it will be coming 15, and d2 minus d1, that is 60 minus 40 is 20 by 2 is 10, so BC is 25. So in triangle ABC you use Pythagoras theorem, and AC square is equals to AB square plus of BC square. See, the only unknown in this is AB, AC and BC is D. So we will put the values and we will get D as 93.30127 mm. So this is the right answer. Now we will move to the next question. So this is a GATE question from the year 2014. See, this is a question of go and no go plug gauge. So I would suggest that do read plug gauge and snap gauge, and particularly go and no go gauge, because they are continuously asking questions from this topic. So now coming to this question, so what does the question is say? This question is saying a go no go plug gauge is to be designed for measuring a hole of nominal dia. A go no plug gauge is to design, the nominal dia is 25 mm, so the D is 25 mm with a hole tolerance of 0.015. So they are saying that the hole tolerance is of 0.015 mm. Considering 10% of work tolerance to be gauge tolerance. So basically work tolerance is upper limit of tolerance minus lower limit of tolerance, lower limit of tolerance. So which will be coming at 0.015 minus of minus 0.015, so it will be coming 0.03 mm. So gauge tolerance is, I'm writing it as GL is equals to 10%, 0.1 of 0.03, which is 0.003 mm. So basically this is gauge tolerance. 10% of work tolerance should be gauge tolerance, and no wear conditions, the dimensions in mm of the go plug gauge as per the unilateral system. So see, the dimension of the go plug gauge is basically written as, it is, I am writing it as lower limit of hole, and here will be gauge tolerance minus of 0. So what is the lower limit of hole? Basically the lower limit of hole is 25 minus of 0.015, which will be coming as 24.985 mm. So as per unilateral system, the dimension of gauge, I am writing it as d dash because d is dia I have written, will be 24.985, 0.03, which is gauge tolerance, and minus 0.0. So if we look at the option, the correct answer is option D. So option D is the correct answer. Now moving to the next question. So this is a gate question from the year 2015. So now we will read the question. The question says holes of diameter 25.0, they have given the upper limit also and lower limit also, are assembled interchangeably with the pins of diameter. In this question also they have given the upper limit and the lower limit. The minimum clearance in the assembly is. So if you go through the figure, you will get to know that how they have mentioned the dimension. So now I will try to draw a figure. Let's say this is a line of 25 mm. Now what they're saying, the holes of diameter, the holes value is above 25. So let's say this is the hole. So this is 25.04 and this is 25.02. This is hole. And what they're saying, the with pins they are being assembled. So the pins are of dia, if you see the value, it is of 25.05. The upper limit is of 0.005. So this is 25.005, and if you calculate it would be 24 point of 992. So now what they said, the minimum clearance in the assembly is. So if you look at the figure clearly, you will find that the minimum clearance is this one. If you go through the figure, so this is the minimum clearance. So what is the minimum clearance? 25.02 minus 25.005, which will be coming as 0.015 mm. So if you look at the options, the correct answer is option B. So the answer is option B. Now moving to the next question. So which of one of the following statements is true? I have already told you that please go through the topic go and no go gauge. So what the question is saying, the go gauge controls the upper limit of a hole. No, this is not the correct statement. The go gauge, the no go gauge controls the lower limit of a shaft. No, this is also an incorrect statement. The go gauge controls the lower limit of a hole. Yes, it's the correct statement. So the correct answer is option C. Now this is again a match the following question, and it's a very simple question. If you have known through all these measuring instrument, that what is filler gauge or what is fillet gauge or what is snap gauge and what is cylindrical plug gauge. So see, filler gauge is basically used to measure clearance or gap between components. So looking at the options, I can say that P is for 3. Fillet gauge is basically used to measure the radius of an object. So Q is 1. Snap gauge is basically used to measure the dia within limits. So R is 2. And finally, S plug gauge is basically used to measure the diameter of hole. So S is 4. So if you look at the options, P is 3, Q is 1, R is 2 and S is 4, the correct answer is option A. We can use the same technique of elimination here again. So see, let's say I am assuming that I am knowing the answer of S. That cylindrical plug gauge is used to measure the diameter of straight hole. So S is 4. So when I will look at the options, this will automatically gets eliminated. Another possibility is this and this one. So now snap gauge, or you might be knowing the value of fillet gauge or filler gauge. Let's assume I am knowing the value of fillet gauge. So what does fillet gauge is doing? Fillet gauge is basically used to measure the radius of an object. So Q is for 1. So as soon as I know that Q is 1, this also will gets eliminated and the correct answer is option A. You so see that elimination is always a better technique in solving match the following question rather than trying to find each and every answer. If you know, it's very good. If you don't know, try to eliminate the options. Now I am moving to the next question. So this is again a similar kind of question which was asked in GATE 2014. Again they have asked in 2016. So now this is basically again a geometrical question, not a metrology question. If you look at the figure, you might be able to solve it again very easily. So see what they are asking. They are saying that for the situation shown in the figure below, the expression for H. They are asking the expression of H in terms of R, capital R, sorry, small r, capital R, and D. So what is basically H? H is this side. So first of all, H, now I am trying to join these lines. This will again form a right angle triangle. Let us say this is ABC. Now AB can be what? AB can be written as, AB can be written as, if you see through the figure, H minus of small r, capital R plus of small r, if you go through the figure. So as AC and AC can be similarly written as D minus of small r plus of capital R, and BC can be written as R plus of R. So now in triangle ABC we will use Pythagoras theorem again. BC square is equals to AC square plus AB square. Now we will put the values. Basically we have to get the value of AB square. So AB square can be written as BC square minus of AC square, which is BC is R plus R whole square minus of AC is D minus of R plus R whole square. So see, we can write it in terms of A square minus of B square, which can be written as A minus B into A plus B. So it will be written as R plus R minus of D plus of R plus R into R plus R. Basically I have what I have done, that I have taken it as A minus of B. Now I will take it as A plus of B plus of D minus of R plus R. So this R plus R and this plus R plus R gets eliminated. So now AB is basically H minus of R plus R whole square. So it will be, we will be getting as 2 of R plus R minus of D into D is equals to H minus of R plus R whole square. So now we will put the value as H equals to R plus of R plus of under root of, if you take D inside and multiply, it will become 2D into R plus of R minus of D square. So if you look at the options, so option D is the correct answer. So option D is the right answer. Now I will move to the next question. So see, this is a GATE question from the year 2016. They are saying two optically flat plates of glass are kept at a small angle theta. This is basically a physics question you might have studied in 12th class physics also. Monochromatic light is incident vertically if the wavelength of light used to get a fringe spacing of 1 millimeter is 450 nanometer. The wavelength of light in nanometer to get a fringe spacing of 1.5 mm. So see, basically what we know, that for fringe spacing is basically defined, delta H is defined in forms of n into lambda by 2 from theory. So now if we calculate that for 1, let's say delta is, for first case delta h is 1, 1 is equals to n into 450 by 2, that this is the 1, for 1.5, 1.5 equals to n into lambda. So we have to calculate the value of lambda, so let it be 2. So when we take the ratio or we divide 1 by 2, so it will become 1 by 1.5 equals to 450 by lambda, which will get getting lambda equals to 450 into 1.5. So lambda is 675 nanometer. So this is the right answer. Now moving to the next question. So this is a gate question from the year 2017. So what they are saying in this question, they are saying that a cylindrical pins of diameter 15 plus minus of 0.02 mm are being produced on a machine. Statistical quality control test shows a mean of 14.995 mm and standard deviation. The process capability index CP. See, basically process capability index CP is defined by upper size limit or specification limit minus lower specification limit divided by 6 of sigma. So now what we have to do, first of all calculate upper specification limit and lower specification limit. So upper specification limit is basically 15 plus of 0.02, which is 15.02 mm. Lower specification limit is 15 minus of 0.02, which is 14.98 mm. So CP will become USL minus of LSL by 6 sigma is this, basically this 2 times, मतलब 0.02 into 2 times, basically it will be 0.04 by 6 into 0.004, which will be basically 10 by 6, and which will be coming at 1.667. So the right answer to this question is option B. Now moving to the next question. See, this is a question in which they are asking the value of central line average surface roughness. Assume, now the question is saying, assume that the surface roughness profile is triangular as shown symmetrically in the figure. See, they have mentioned it in the figure by mistake, it's not printed here. Basically it's, the figure is basically like this. So if the peak to the valley height is 20 micrometer, the central line average surface roughness in micrometers. See, the RA is basically defined as h by 4, where h is basically peak to valley height. So here the peak to valley height is 20 micrometer by 4, which is 5 micrometer. So the right answer to this question is option A. It's a 5 micrometer. Now moving to the next question. So this is a gate question from the year 2017, and this is again a go ring gauge. So please do carefully read the topic go ring and no ring gauge, because they are continuously asking questions from these topics. So now what the question is saying, a cylindrical pin of 25 plus 0.02 upper limit and lower limit is 0.01 mm diameter is electroplated. Plating thickness is given to as, so I am first writing the data that the dia of pin is 25, 0.02, 0.01, and the thickness plating, I am writing PT, plating thickness as 2 plus minus of 0.05 mm. Neglecting, they have mentioned neglect the gauge tolerance, so we have to not to consider the gauge tolerance. The diameter of the go ring gauge, the diameter of the go ring gauge is what? So see, what the thing is that this, let's say this is a pin whose they are saying that this is a pin and whose maximum possible dia is 25 plus of 0.02, which is 25.02 mm. Now what they are saying that it is been electroplated, plating is done. So an electroplating layer is being provided on both sides. Since electroplating is done, so what is the thickness of electroplating? Thickness of electroplating, I am writing it as T is equals to 2 times, because it will be on, if you consider it radially, it will be on both sides. So 2 times of, again I am considering the maximum value, which is 2 plus of 0. 0.005 mm. So if you will calculate 2 point, yes, it's correct, 2 into 2.005, it will be coming at 4.01 mm. Now, so if a gauge, let's say if a gauge has to check the hole, if it has to pass through it, so the maximum dia of the gauge, so the dia of the gauge, if it has to pass through the pin, would be of the maximum dia of the pin plus the thickness, so it will be 25.02 plus of 4.01, it will be coming at 29.03 mm. So the right answer here is 29.03 mm.